Hi Cindy, I wanted to make you a quick video in regard to your Unit 1 assignment. Just the last few questions in terms of how you're doing them is different than what I was looking for. If you look at some of the examples that are in the content section for the finding the limit in this chapter, then you'll see that when we have this situation, such as a question like B, where the denominator is equal to x plus 4, and just subbing in a value of minus 4 for x is going to create a situation where we end up with a 0 denominator, so we have an undefined value. So basically, if you were graphing this function at the value x equals minus 4, you've got what we call a discontinuity, or a hole in the graph, when x equals minus 4, because there's no corresponding y value to go with it. It's infinity at that point, or undefined. So what happens with functions like that is sometimes that discontinuity is removable. And what that means is that we can actually manipulate the equation that we were given. So I'm just going to write it over here because I don't have a lot of space. I've got x plus 4 and x plus 2 as factors of the trinomial on the numerator, and x plus 4 in the bottom. So now if I divide that x plus 4 terms out, I just have x plus 2 left. And the limit as x approaches minus 4 of x plus 2 is what you get when you just sub that value in, and so that would give us minus 2. So you've got that idea over here, and it did lead you to the answer of minus 2. But in terms of discontinuities in functions, that's generally not how we handle them to do the left and the right limit. We generally manipulate the equation so that we are able to sub in the value that we're given for the limiting value, and so that we're able to get a value. If we can't manipulate the equation and make it so that we're not going to get 0 in the denominator, then that just tells us that that's not a removable discontinuity. There's an asymptote for the graph at that value, and that we're never going to get a limiting value there, that we can't find the limit. Okay, so for C, if we do the same thing and we factor the numerator, we're going to have this, and factoring the denominator as well gives us this. So simplifying that and then substituting x equals minus 2 is going to give us minus 2 over minus 4, or 1/2. And again, you've got the answer. It's just getting there that's kind of a different approach than what you're using. Now I just want to go over to the next slide here, because I've got the solutions that you gave me for D. I think it's C and D. No, it's D and E. Sorry. And I want to have a look specifically at this one here. When you have something like that, then you have to manipulate this equation in a special way, and that way is called rationalizing the denominator. We take 3 minus root x over x minus 9, and we're going to multiply the top and the bottom so we don't change the function by 3 plus root x over 3 plus root x, like that. That's called multiplying by the conjugate, or rationalizing. And the reason that I'm doing it this way is that I've kind of created a difference of squares in terms of the two binomials being multiplied here. When I multiply that binomial on the top by the second binomial, I end up with 9, and then it's going to be plus root x minus, 9 plus 3 root x minus 3 root x, which makes 0, and then minus root x squared, which is just x. So on the bottom, I still have the x minus 9, and I'm going to multiply by 3 plus root x. And the x minus 9, or the 9 minus x, can be transformed so that it's the other way around just by taking a negative out. So if I take a negative out of that factor at the top, then I've got my other two factors. See if I can squeeze that in. And those guys are going to cross out. So now I have minus 1 over 3 plus root x. And if I substitute in the limiting value, which in this case was 9, then I'm now going to have 1 over 3 plus the root of 9, which is 3, or 1 over 3 plus 3, which is minus 1 over 6 for the limit. Okay, and again, 1 over 6 is decimal 0.17, but when we have equations like this is not how we approach finding the limit. The only time that you would do that is when you're asked for the limit from the left or the right, and that's signified by that little minus or plus sign. Or another case would be when you're given the graph and it shows a discontinuity in the graph, and so you would test from the left and the right to make sure that the limits are equal, and then you can say the limit exists, okay? Like the ones in the questions below. So those ones are fine. When you've got everything right there and your form and everything is perfect, but the ones at the top of the page that we just talked about, you need to do those in this way where you're actually algebraically manipulating the formula and then actually subbing in to calculate the limit. So I hope that helps. Please email me if you don't understand that, and I can definitely explain it some more and send you some other resources.